All right, so let's talk about even and odd multiplicity. If a polynomial function has a factor that is repeated, these duplicate roots are labeled as a multiplicity All right, so if f has a real 0 c of odd multiplicity, then the graph will cross the x-axis at c, 0. If f has a real 0 of even multiplicity, then the graph of f will touch but not cross the x-axis at c, 0. Okay, so I forgot my parenthesis there, close parenthesis. All right, so let's look at one. So let's look at example 2. Oh, it disappeared again on me. All right, so let's scroll down a little bit here. And so it says, use a calculator to sketch that graph there. In the graph at the right, label the zeros and describe the behavior of the roots. So they gave me a picture of the graph here, which we could find by using our calculator. And we can see where our zeros, our roots, our solutions, our x-intercepts all are, because remember they're all the same thing. And so I can see that I have one here at x equals 2. Notice here it crosses, so it's going to have odd multiplicity. Notice we also have one here at x equals 1. It touches, but it doesn't cross it. And so therefore that means this is going to have even multiplicity. All right, so let's go back to our problem. So we can see here that my first factor was x plus 2 cubed. So x plus 2 cubed. Remember, to find a 0, an x-intercept, a root, a solution, you're going to set it equal to 0 and solve, because the entire equation is already factored for us. And so this 3 right there as the exponent, because remember now we could write it out as x plus 2 equals 0, x plus 2 equals 0, and x plus 2 equals 0. Set them all equal to 0, and we would get -2, -2, and -2. So the easier way is to say, okay, well, we have an x plus 2 equal to 0, which gives me x equals -2, and then because we had that little exponent there that was a 3, we say multiplicity of 3. And then my other factor was x minus 1 squared. So x minus 1 squared to find its 0, its solution. Now, just using what I just said there, we can say that this is x minus 1 equal to 0, which means x equals 1, and because it has that exponent of a 2, we can say multiplicity of 2. Now, what that tells us as well is when I go back to this first one, x equals -2 multiplicity of 3, that this is an odd multiplicity, and therefore it's going to cross. When I look at the x equals 1 multiplicity of 2, I can see that that's even multiplicity, and therefore even multiplicity is going to touch but not cross it. Alright, so that should help with that part, and so I'll make the next video for the next part.